Yeah, I use that by law. We have to, yes, we have to put men and women by law, so they are.
Nothing. Should we erase this board?
They probably moved to the new track.
Yeah.
Okay, so the January. Yeah.
Oh, excellent.
So are you a regular at these?
More or less. So first of all, I no longer work for Mark.
Oh, okay. Last time you said.
Yes, but the company where I work now has an interest in HBase. I moved to a cloud storage startup. Cloud storage. It's called the Terra. Oh, it's still small, very small, very nice people. My first Mark in 1 year.
Okay. What's his name?
Mark Fleischman. He's German. He's incredibly nice. He's like, these are the nicest, brightest people I've seen as a company. I've seen for 20 years. And they're trying to be very fast. So we're hiring whoever is still available from the working at us. But storage is a very tough one. I'm very skeptical. Well, so the notion is that we don't want to sell just storage. We want to sell fully integrated analytics platform that leverages the performance of our storage. So the long-term goal is to be able to offer. I guess the best description would be a private analytics cloud. I'm not sure how well the three things would fit together. I'm somewhat skeptical about the notion of private clouds because I don't see that many businesses can either be or can justify the type of internal cloud that Facebook we've been going around and talking with people trying to find out what their data needs. I think the largest deployment that anyone has mentioned is 160 petabytes. 160 petabytes, even if we were able to find the customer with over 160 petabytes per month, I don't see how they could keep the company alive, because when you're selling storage, effectively what happens is you have to structure your entire operation within the markets that the storage vendors will allow, right? Because at the end of the day, you're buying disk drives and storage media like that and marking them up. The software is what allows you to mark up, to charge a higher markup for the disk. So it's a essentially that means
Yeah, retry.
structure.
Oh yeah. Yeah.
Something like that. Within this
Cooling, packaging, application.
So it's a big question. You have to keep it open source. You have to keep it Amazon. Oh, by the way, someone called me from Amazon. A recruiter called me from Amazon to ask me if I'm interested. If I'd be interested in moving to Seattle and managing the project, the logistics project for the drones.
Oh, really? Oh,
No, thank you. Well, yeah, but it's cool. I mean, if you don't really have legal issues, liability issues, airspace control, safety and security, and all that, anything else, maybe someone will come and there isn't a legality person. Right? So, how are you doing? Oh, so, by the way, one of the interesting things about the Terra is the founders of German and Swiss. They see very old-fashioned. They actually have offices.
That's a rare thing.
Right, and not only they have offices, but the first thing they did after they moved into the office, they went straight to IKEA and they bought furniture and chairs and sofas, cases. So it's a throwback in some ways. So we just raised $10 million from our person, and from the person Pradeep. No, Pradeep is? Pradeep is the founder of Juniper. So there's somewhere in the back of the page is process administrator. But pretty much like everybody else, they're drinking their own Kool-Aid. And but they're not drinking as much as Mark Himelson's company. Mark Himelson's company. That's I couldn't have imagined what he's trying to do. Basically, he's trying to do something that will take about less than 3 minutes of simple math to understand that it cannot possibly work. But they don't want to do the simple math. So they want to directly analyze values, do a lot of hardware. Remember, I asked you last time we met, I asked you if Facebook or anyone actually using some lab systems, big system development.
Yeah.
That's what I thought.
Okay. How are you looking?
More memory than anyone. They're, I don't think they're going to make the milestones that the investors want. Can you speak this year? Okay. Wow. Well, the snow is terrible.
At that time.
Yeah, because it's higher. So I went for the first time this weekend because I think yeah. Well, it was a lot of snow and very heavy and wet, and the winds were very strong. So the Mount Rose actually closed. Right, so because of the high. So I did get the season pass in Mount Rose this year. it's an unbelievable deal. I bought it last year for $400. Seasonal glasses. I don't think I'm gonna So I'm trying to go this weekend. Not for me. Yeah, I know. Well, I know it's a long weekend for most people, but I'm going too fast. We're all fast, right? So it runs February 17th to February 20th. Until February 17th. And then the following weekend, I'm also toying with the idea of flying to London for just a weekend. Yeah, I know. But where else? Where else last weekend?
Seattle. In terms of token offices, Seattle. Just opened an office.
Anything news, Ralph?
Actually, they bought a novel. So, but people have asked for Ralph.
Like there's a lot of talent there. One thing that I found mind-blowing the last time I went there, so I go back and forth between what we went to the town, I noticed because most of the high-tech companies typically visible from one of the major highways because they're cutting clusters like this. So Microsoft has not one but three R&D offices. VMware have to. NetApp have to. Just I would have thought, but maybe they. Yeah, I noticed that. So you know, John Galloway is its Salesforce, and Suzanne Hinkler. So Suzanne was at Excel. Oh, okay, so maybe she was the performance person at Excel. Okay. So I'm not surprised. And we called kind of this resignation like a week or two ago. We called. Yes. If we continue went to Salesforce, I would suspect we could go to Salesforce. So, they have this huge project. You must have heard about it. Sorry,
Well, I guess it makes sense.
I have that. My intuition is that this is going to be successful because they have too many people working on it. They have too many people working on it, and they have a bunch of conflicting requirements. They have to make, basically, they have to make this automated happen, including part. And yes, it is. What's the point? Right. So. Maybe something so that's what Suzanne did. That's what we done. And if I didn't have to connect your way in the system, I would have done that. But I'm skeptical about most of the companies. If you look at the failure rate, I'm not skeptical about sales. So that would be an improvement. But taking the bus to San Francisco, driving to San Francisco would be great. Well, they have, right, so there's something to split this out. Yeah. No, but sitting on a bus for an hour this morning, every morning an hour, having flexibility to do that but there at least is very nice. So San Antonio Shopping Center, where the promotion so plenty of people walking distance. Stuff and it's a sort of for sorry, Mark Milan is achieving so far. And that he's managed to get this like every single people. Well, I mean, well, except for him. Right, Teresa was very often that he made no reason. Because he made Focus on is the person behind is what some people so to put all the legacy stuff in the doesn't make much sense. No, Emma has Victor rights.
Oh, okay, I didn't know that.
However, Victor rights is being brought into
Okay.
and if you have to name for marketing business, Victor rights is not it's concept. So the working goes to Lisa, he made pretty much he called me, made me and
Let me just turn that on.
so
Yeah. Can you test it out?
yeah. I believe luckily he spent half a day.
I know, I just have that.
Well, the founder, yeah, so what it is story, exactly the kind of stuff.
It is. I think it has to get better.
So one is
If you must.
highly
If you
Even if you don't, the default Mongo and the default
I'm not sure how successful the company
Wait,
yeah. Oh, yeah.
is. It's a nice environment, but
Can do.
trying to raise money for
I
it.
think it's
Still, it's very hard to do that.
I think it's beautiful and stuff.
So tell me what you think about
People will use as key value store.
a system designed to run a
But again, it's
computer
kind
and
of
staff.
but it's
Audio.
so that's the thing that you're able to
It's not so much.
Oh, really?
No. Very high density.
After last year? Well, the guy basically said, do you have that?
But not the same thing you have to have. You have to lay out your families to organize them.
Yeah, but
That can break
No one's such a fish, but you're actually. Well, yeah, it's not that.
You design differently for every other know how to
They're all making it.
Pretty soon. Not all actually. let me know what
Just go back to the value. So yeah, if you get the value that's probably one. It's not one. Oh, that's okay. I wouldn't put the whole module in one copy instead of all breaking down and use every module in the document. Yeah, we got a whole line here. We're still safe to see. Why would that use the
Hey everyone, thanks for coming out and visiting us at our newly revamped Continuity HQ. We're happy to have you, and if it's not obvious, we're always hiring, so let's keep that in mind. Before we get started, if anyone hasn't registered for HBase Con yet, of course I'm sure you all have, we have the special code HBase COMM for a 20% discount. So make note of that if you're planning on attending and haven't signed up yet. And with that, I think we'll get started with our first presentation, which will be me and Alex Vernow here, talking about how we've built transactions on top of HBase. So, I'm Gary Helmling. Been a long-time HBase committer and PNC member. Now working at Continuuity. This is Alex Vernow. Also a long-time HBase contributor, also working at Continuuity, and we're going to give you an overview of how we've developed transactions on top of HBase for some of our use cases. So first, a brief note on who we are. We build Continuuity Reactor, and you can think of it as the first scale-out application server for Hadoop. It basically makes it easy to build big data applications on top of Hadoop and HBase. And the team here has a lot of experience contributing to and working with open source projects. So we're going to give an overview of transactions in stream processing. They're key to the stream processing frameworks that we build in Reactor. And then we're going to dive into the details of our implementation, talk about how we've made this work. Alex is going to give an overview of how we actually write data at HBase and how the transactions work there. And then I'll give some details about the server-side implementation. And then we'll wrap up with a couple of thoughts on what's next. So, as I mentioned, the Reactor is an application server. It's built on top of Hadoop and HBase. It makes it easy to build data pipelines for stream processing, storing and querying data. Each stream is what we call a flow, and it's a real-time processor with an exactly once processing guarantee. That's what we view as the key value. And each flow is comprised of one or more flowlets which do the actual processing, all of which is done with asset guarantees in the form of transactions. What does flow look like? Well, you can see here all the green boxes represent individual flowlets. These are Java code that does some type of processing. They consume entries off of queues, and they may emit then new entries as a result of processing on more queues. And at the same time, it's often pretty useful to persist some data to an HBase table. Of course, for any real system, you often want to build more than one of these, and the aspect that you'll want to make use of is having different flowlets share the same data sets between them. This is all well and good up until the point that two flowlets try to actually update the same cell at the same time, and then all hell breaks loose. But good news, everyone. With our transactional layer, we make it possible for all of the operations within a flowlet to complete atomically so that they're all visible, or should we run into a conflict, they all fail at once. So what are transactions? I'm sure everyone's seen the slide a million times before, so I won't spend a lot of time on it. But the key elements are atomicity, consistency, isolation, and durability. And that's what we're seeking to provide. What about HBase? Well, HBase is a great elastically scalable platform with a number of operations we like to make use of. It has some really nice features, including atomic operations, atomic read, modify, write operations on individual cell values, such as check and put, check and delete, increment, and append, as well as even support for atomic batch operations, as long as all the rows that you're updating live in the same region. But if those rows happen to span across multiple regions, there's no atomic support for that. At the same time, there's no atomic support for updates spanning multiple tables or spanning multiple RPC operations. So as a result, we've had to create an additional layer that provides some extra guarantees to bridge those gaps. And with that, Alex is going to talk a bit about the implementation.
Yeah, so how do we implement all that? So the approach that we took is a mix of two commonly used approaches: is multi-version concurrency control and optimistic concurrency control. So HBase allows us to store multiple values with different timestamps in a cell. So we store transaction ID as a timestamp, and we use it later on for isolation. We'll take a look at that. We also defer conflict detection to the commit phase. And by conflict, I mean two overlapping transactions modifying the same row or the same cell. So why do we do optimistic concurrency control? For the applications that process high volumes of data at a high throughput, it is a very good fit. We avoid costs of locking. We also we don't have to care about deadlocks and other stuff like that. But at the same time, we have to be careful because conflicts are more expensive in this case. And especially if we have to roll back whatever we persisted before. So when you design your applications, you have to think carefully and design it in a way that ideally conflicts are just avoided by design. This is how transaction system fits in our system. So we have multiple transaction managers, which are coordinated through Zookeeper. And we have multiple clients, which are user applications, user programs, that communicate with transaction manager and at the same time write data to HBase. So let's take a look at the transaction lifecycle. When client starts transaction, it talks to transaction manager, which creates new transaction based on its current state and puts transaction in progress list. Using that information, client performs writes to HBase. It writes transaction ID to timestamp of the value they writes to HBase. And then when it tries to commit, it communicates to transaction manager again. It sends the list of changes, and transaction manager checks if this transaction can actually be committed. So it compares it with whatever was committed before. And if everything is okay, we just put it in complete list, and this list is visible to others. So the changes made by this transaction are visible to all other transactions started after that. If things go bad, client tries to roll back the changes so that no junk left behind in HBase. And upon successful completion, it tells that to transaction manager, and since there are no changes in HBase left, we can simply say that this transaction is visible to others. If things go really bad and we cannot roll back changes that we did, for example, HBase failed or it was unavailable at that time, then we tell to transaction manager to put this transaction ID into invalid list so that no other transaction will ever see. Transaction can be moved from in progress list to invalid list also when transaction times out, when, for example, client crashes. At the same time, client can also, on its own, based on the application logic, it can choose to abort transaction. Then we go through abortion steps again. So let's take a look how what we actually do when we write to HBase. So we start with a situation when we have value 10 in row 1, column 1, which is visible to others. It was made by a transaction that is visible. So first client starts transaction, and it gets write and read pointer from transaction manager based on its current state. Manager puts this transaction in progress list and increments write pointer. So when client tries to increment it, it appends another cell with timestamp equals to its write pointer. So then next client starts transaction. It gets next write pointer. Write pointer gets incremented on manager, and this new transaction ID is got to the in progress list. When again client increments the cell value, it uses its own timestamp. At the same time, second client got transaction started by the first one in excluded list, so it doesn't see what transaction first was what it wrote before, and then it successfully commits. Upon that, transaction moves from in progress list, and it is now visible to all others. Now, when first client tries to commit, transaction manager detects a conflict because there was another transaction started after it, but committed first. So it cannot commit, and the client tries to roll back. In this case, it will just delete this cell, and it is now safe to put it in visible state. So it is moved from in progress list. So that next time, and then we also increment read pointer to the 1003 because all other transactions prior to that were completed. So next client starts, it sees the correct value done. Now let's get back to the situation where it detected conflict. In this case, when we try to roll back, let's assume that we failed to do so. Let's say HBase went down. We have to tell transaction manager that this transaction is invalid. And manager puts this transaction in invalid list so that next transaction has it in excluded, and whenever it reads, it doesn't see it. So now Gary will talk about how transaction manager is implemented.
So we've seen some details about how transactions work in terms of writing to HBase. I'm going to talk a bit about how things work on the transaction manager server side. The transaction manager is responsible for a few things. It provides this monotonically increasing timestamps that are assigned as transaction IDs, and of course it's important that each one of those be unique so that no two clients try to write to the same timestamp. It also maintains state on all the in-progress, committed, and invalid transactions, and that allows it to hand that information back to clients so they can filter out data, as well as allows the transaction manager to detect conflicts. And it, of course, detects conflicts on overlapping transactions. Now, a transaction consists of a few key values: write pointer that it uses, as you saw, to write out new cells to HBase, read pointer that it uses as the upper bound timestamp when reading data, and the set of excluded transaction IDs that it should skip over, either because they're in progress or data from an invalid transaction. There are a few things that we want the transaction manager to be. Since it's involved in the client read and write requests, we want it to be simple, and we want it to be as fast as possible. So all of the required state is maintained in memory. But we also want it to be robust and resilient to failure. So since it is potentially a single point of failure, we want to be able to recover what the transaction state was when a new transaction manager takes over. So all of those state transitions are persisted to a write-ahead log. And in the case of failure, a secondary transaction manager can simply replay that log in order to do point-in-time recovery, and failover can happen quickly. So let's take a look at request processing from the transaction manager point of view. So say a client request to start a new transaction comes in. Transaction manager increments the write pointer, adds it to the in progress list, and appends that transition to the current write-ahead log in HDFS. If that same transaction later completes, it's removed from the in progress list, added to the committed list for conflict detection, and again, the state transition is appended to the write-ahead log. Now, this is great because in the case the primary transaction manager fails, a secondary can take over. We can replay all those state transitions and recover the transaction state to the point in time of the failure. But the longer that the system's running, the more entries we append to the write-ahead log. It's a classic write-ahead log problem. Longer recovery takes. So in order to bound recovery time, we also have a process to do periodic full snapshots of the transaction state. And this allows us to recover from just the combination of the most recent snapshot plus any incremental state changes from the newer write-ahead logs. So let's take a look at that process quickly. Again, we have a transaction manager currently running and appending changes to transaction log A. When we start the snapshot process, the first thing we do is roll over to a new write-ahead log. And atomically, we also take an in-memory copy of the current transaction state. At this point, we can resume servicing client requests, and any new changes will be appended to transaction log B. We then asynchronously write out the state snapshot to a new file in HDFS. This completes successfully. We then no longer need transaction log A, as we can recover state from the snapshot file on transaction log B. Should this fail in the middle of writing out the snapshot file, we can always recover from the previous snapshot file, if one exists, plus all of the entries from log A plus log B. Now, as we saw before, clients may sometimes fail to roll back changes that they've already persisted. And this can cause a problem in that these entries will accumulate in HBase, and we don't want them just sitting around forever when they're essentially invalid data that we don't care about. So we've implemented a region observer coprocessor that hooks into the flush and compaction processes in each region. And by looking at its own in-memory copy of the recent transaction state, it can filter out data from those invalid transactions and allows us to purge out data that would otherwise sit around unused. So let's take a look at that process in some more detail. Here we have an HBase region on the right, and the data janitor is periodically refreshing its own view of those transaction state from the latest snapshot file. When a memstore flush happens, the data janitor will override the region scanner that's used in the flush in order to write out new entries to an H file, in order to include all the data that should be there, but filter out data from invalid transactions. So we start the scan at the most recent version. This is from an in-progress transaction, and so we need to include that. We then move on to the next version. This is from a committed transaction, so again, we include that. And move on to the next row, and this is from an invalid transaction, so we simply skip that. At this point, our flush is complete, and we no longer need the data in the memstore. So, you've seen an overview of our transaction system. As users of HBase ourselves, we believe that a lot of people using HBase could really make use of features like this. So we're considering ways that we could possibly open source this project. And while we found the transaction manager to be very performant ourselves, and it has never been the bottleneck in our applications, we're still looking at ways that we can continue to scale it, and by distributing load across, say, multiple instances, partitioning transactions across those. And finally, transactions are only useful if all of the participants in a given operation can understand them. So we're looking at ways that we can integrate this across other data stores that support transactions. So with that, let's open it up for any questions you might have.
Yes. Yeah, I had a question about the list of the lines of the transaction. The transaction volume is large, and this list of the transactions is also very large. Did you see the volume?
So yes, the in-progress list, do you want to handle this?
So yeah, basically we have to transmit the full in-progress list, right, of transactions. Usually at the same time in progress, there are not a lot of them, right? There are like thousands, maybe like tens of thousands, right? So it is not as big, right? At the same time, there are ways to improve that because like in progress lists, they usually go into sequence, right? So you can basically figure out what is the range, right? So there's a way to compress that. So
when you're reading from HBase, where is the exclusion? Yeah, it's like 10,000 progress transactions, so you get like 10,000 one roll to just figure out if you need one or you go.
Yeah, well, right now it is happening on the client. There is a part that does it in coprocessor on the server side for some case, but the thing is that even though in progress list is very large, it never happens. It usually not happens that like all these in progress transactions change the same way. So the list is short, and it usually like doesn't really affect it.
You guys mentioned it's the implementation is Omid style. So did you guys actually try Omid? And what were your thoughts?
Okay, so yeah, there is an open source Omid project from Yahoo. What ours does is it does a little bit more. It allows you to do deletes comparing to that one. It also what's different? Let's see how else.
It's very similar.
It's very similar. That's why we like call ours like Omid style transactions. It's designed by that.
So how is the master doing conflict detection if it does not know what the abuse client make?
So when a client tries to commit, part of what it sends to the transaction manager is the change set that it's applied. So the transaction manager is looking for spatial and temporal overlap between the recently committed transactions and their change sets and what's being requested by the given client.
Do you have any benchmark to show how much slower it is
compared with no transactions, I mean, it's going to depend a lot on the workload, I think. There are also different ways of tuning this a bit. So the transaction overhead is basically pretty fixed on a transaction basis, so you can essentially batch updates within a single transaction if the individual transaction overhead is dominating. But I think it would be, you could compare a transaction overhead and no transaction overhead for a given workload, but I believe it would be a little hard to do generically.
To add to that, you will see overhead if you have a lot of conflicts, right? If there are no conflicts, it's just the cost of 2 RPC calls per transaction, which is fairly like over the network, so it is very fast.
So for the data, since the transaction manager needs to record the new rows committed, right? And which means like the same data will ready to one log twice or once.
No, it's not. It's not. So the question was whether transaction manager has received all the data that they were changing in HBase. It's not like that. So we only have a notion like a change ID. So depending on your use case, you can configure it to be like a row key, for example, and it doesn't matter which column you're changing, or you can make it more fine granular, or even higher, less granular. And it depends on your workflow. But yes.
Okay, so for one of your actual use cases, have you managed to benchmark to determine what's the ceiling number of transactions per second?
Yeah, I mean, we're basically bounded by the wall on number of transactions per second we can handle, and the wall implementation is very similar to the HBase wall implementation, maybe not so surprisingly. So with concurrency, we see tens of thousands per second. Yes.
Can you define the transaction so can you define compensation?
So I'm sorry, I didn't catch the last part.
Compensation.
Can we define transactions declaratively, and can we define compensations?
In case of
I see. So like a callback or something in the case of rollback. So the current transaction system is kind of tightly integrated with other portions of our system. I mean, it's basically transparent to clients, so there is no additional action. It's basically an all or nothing guarantee provided to users of our client API. I mean, I could see such a feature being useful as a more generic facility if this is kind of extracted out of our current APIs. Yes.
So what would scan see while transactions are going on?
So the question is, what would scan see while transactions are going on? So this is actually a good example of what scans would see while a transaction is going on. The scans would, for a currently running transaction, would be starting at current read pointer, which is 2003 because nothing newer than it has committed. So they'd be starting here and just going back in the version history, say that 1003 here was invalid, it would skip that and move on until it found a valid visible transaction or a valid visible version. Yes?
What are the number of in-flight, in-progress changes you can have? Like, is there a number of limits configurable or ceiling? In-progress edits to a single record.
So do you mean in-progress edits to a single cell?
Yes.
There is no limit other than, I suppose, memory bound the in-progress list and performance bound on costs of skipping all of those versions. So, I mean, in specific cases, you're going to start pushing against kind of characteristics of the system that will hurt performance. All right, thanks everyone, and let's move on to the next presenter.
So while we're getting the slides ready, just get introductions out of the way. My name is Andrew Purtell. I work for Intel. I'm an HBase committer, and I'm going to talk to you about our upcoming HBase release 0.98, which I was the release manager for. So I'll talk about the snazzy new features in this release and why you should rush out to download it as soon as we can finally get a release candidate out the door. Currently being voted on, probably will close successfully this time. All right. Great, thanks, Gary. Okay, so here's the highlights of what's coming up. We've done about 230 bug fixes and a few new features since the 0.96 release. The highlights are the ability to do reverse scans, permission checking for coprocessor endpoint executions, transparent server-side encryption of H files at rest, per cell ACLs, visibility labels, so like the way Accumulo labels cells, we can do this. Striped compaction, map reduce over snapshots, a new way to stream scan results from the REST gateway, significant performance improvements, including a new and improved write-ahead log write threading model, which is better, shows higher throughput at high load, API cleanups, and many bug fixes. Dare I click that? That was the wrong move. Is there a way to get rid of that thing in the morning? No. Oh, well, it doesn't matter. Okay. Oh, cool. Okay, so the release criteria we used for this branch was that HBase 98 should be wire compatible with 96. So if you have an HBase 96 cluster running, you can stage HBase 98 to it node by node, and it will seamlessly interoperate client side and server side with what's currently executing, as long as you don't enable any of the new features in 98. If you want to take advantage of the new features in 98, you have to complete a rolling upgrade and then make a configuration change and then make a cluster restart. It's fully compatible with all of the earlier on-disk formats from 96 and Zookeeper metadata and whatnot. There is a upgrade path from 0.94 release to 0.96. It also works if you go from 0.94 to 0.98 directly using the same procedure. We wanted no significant performance regressions from 96 using the default settings. And one caveat as far as release compatibility, we decided that binary API compatibility for this version was not a release criteria. So what that means is you may need to recompile your applications or application code that touches the HBase client jars, client API. So if you're doing a node-by-node staging, it's fine. Just recompile your application and stage the application bits with the client updates on the new nodes as you're bringing them on. But what you won't be able to do is keep other pieces in place and just drop a new HBase jar in place without recompiling your application potentially. So let's start talking about the new features. So reverse scans. There's a new option on the scan object called set reversed. Set this to true, and now instead of iterating from your start key to your end key, it will iterate from your end key to your start key. And the performance is pretty good. For the reverse case, it's a few percentage points slower than forward scanning in CPU-bound tests. So the big impact here is if you are trying to iterate over your HBase data in both forward and reverse sort order, you now no longer need to keep a separate table in reverse sort order, or either an index or materialization of your primary table. Next, we've introduced security checks for coprocessor executions. There has always been an execute permission in the HBase ACL model, but until '98, that bit was just ignored. So now this is off by default, but if you'd like, you can enable this feature, and now once this feature is enabled, users will not be able to execute coprocessor endpoints unless you grant them specifically permission to do so on a per column family basis. In the back end, on the server side, HBase cells, affectionately known as key values also, can now be associated with an arbitrary number of so-called tags. These are bits of metadata that are carried along with the cell, actually stored adjacent to the cell on disk and in the write-ahead log. You cannot access this feature from the client. This is something that is a server-side only facility at this time and probably for the foreseeable future. But coprocessor applications can use this feature, and in fact, this is how we've based some of our new security features. This is how we do the persistence for some of our new security features. So coprocessors, anyway, can manage their own user-defined tags. And as you can see, how this is laid out in storage, tags just appear beyond the value sequentially with the rest of the cell data. There's a new HFile version, HFile version 3. The key difference with HFile version 3 is it knows how to persist tags. You can enable this with a site file change. Once you've done this, all of your HFile v2 data can be read, of course. Any new files written will be written in v3. If you're doing a migration from v2 files to v3 files, run a major compaction. By the time that completes, the migration will be finished. This is required for some of the security features, transparent encryption, per cell ACLs, and visibility labels. Transparent encryption essentially protects the data at rest in HDFS. The use case that we're trying to protect here is maybe the HDFS permissions are improperly applied, so although you've set access control at the HBase layer, someone can get in and read the H files directly at the HDFS level. So this obviously defeats that line of attack because the data will be in encrypted form. Likewise, if you're, some organizations are sensitive about making sure that, or very concerned about making sure that the data that they're discarding on, say, failed disks doesn't contain any sensitive recoverable information. And so if you're always encrypting data to be persisted, then you can have a certain level of assurance that leaking information like that isn't possible. So it's a compliance device. So how this works is, so first you enable HFile v3, and then you also set a schema attribute on the column family. Once you've done that, any H files that are written will be encrypted. This is how it looks at the system level. There's a new encryptor introduced at the H file level and also the write-ahead log. Make sure that okay, and and that is interesting, right? So the read and write paths involving H file encryption overhead is not terribly significant, but the write-ahead log is a different case, and so I think that we have some future work to do, try to mitigate some of the performance impact of having encryption in line with the write-ahead log, because this is going to bring the ceiling down of your overall write throughput in the HBase system, right? And it's unfortunately necessary because if you're encrypting data for H files, but not in the write-ahead log, you need the write-ahead log also going to the same volumes, and you will have sensitive information potentially leaked on disk. So we simply encrypt the entire write-ahead log if you have transparent encryption enabled also. But some future work there would be doing the encryption in the write-ahead log selectively only for the column families that are actually sensitive, using perhaps multiple logs,
to bucket all of the writes that require encryption, at least to only one log file, that sort of thing. Per cell ACLs extends the existing HBase ACL model to the cell. So before you could set ACLs on the table or on the column family, now you can also do it on a per cell basis in your put or append or increment any mutation that is writing data. You can add an operation attribute on the operation that you're sending over to the server, which contains the a serialized ACL to apply at read time. And a key thing to consider for ACLs is how you apply the ACL. Early on in the design, we were thinking, well, maybe we just have ACLs refer to something stored elsewhere, security policy stored elsewhere. So you could update security policy in one location and have it apply to all of the ACL, all of the individual values so tagged. We decided that that might be difficult to reason about. So to make that as simple as possible, we say that the ACLs on a cell are time-stamped with the cell data, and so the security policy in effect on a cell is exactly the same scope as the data in the cell in terms of visibility. Visibility, excuse me. Visibility labels is a feature that is essentially parity with Apache Accumulo. Apache Accumulo and now HBase allows you to set visibility expressions. These are what they look like on a cell basis. So you can tag in. So ACLs and labels are two ways to express security policy. An ACL is a list of explicit grants on a cell, who can do what on that cell. And labels instead don't say explicitly who is allowed to do what. They just say this is some essential characteristic about the data in the cell. Maybe it's a sensitivity level. Or it could be, in this example here, the probationary thing, some essential characteristic of the person who's trying to access the data. So it turns the decision on its head. The decision is made later. The labels are read and a policy is looked up, and at that point it's decided whether the user has the ability to read that in particular information or not. And how we do that is when you are using HBase query facilities, either a GET or a SCAN, we initialize the RPC context with the set of effective labels for the particular user. And when going over the cells that satisfy the query, we simply evaluate this binary predicate, and if the evaluation is true, then the data is visible to the user. False, it's not. There are new shell commands for managing the set of labels assigned to a user, and new facilities on gets and scans to say what labels are in effect at a particular time. These are roughly equivalent to how the Accumulo API works and how its shell commands work. So I'm sure it's not exactly 100%, but you can drop an application that was designed for Accumulo in place and use these HBase facilities, and it should function equivalently. And I can imagine that trying to do that in some sophisticated cases will cause edge cases to emerge that will result in some JIRAs. So with that caveat. We've improved the write throughput of the write-ahead log in this version significantly. It's about 15% better at high concurrency for writes. And I think this work also cleaned up the code and laid the groundwork for making multiple walls a reality, which should provide further throughput increase in future versions. Striped compactions is a feature that I wouldn't call an experimental status, but it might be a little bit difficult to use.
So striped compaction is one of the first users of the new pluggable compaction that went into HBase 96. So you can swap out the default compaction policy management with the striped compaction policy management, tune it, and depending on the ingest and access patterns of your application and how you've configured striped compaction in particular, it can reduce the variability of read latency, and it might reduce write amplification. But I would urge you to consult the documentation, the HBase online manual, and the JIRA in question to learn more about this feature. MapReduce over snapshots. If you are looking for very high throughput processing over HBase data that's relatively static, you can create a snapshot which dumps all of the table data at that current state out onto disk into H files. And at that known good point, you can then run a MapReduce process to look at each of those H files concurrently and do some processing in situ, right, with your MapReduce code. So this is like table input format, except it's reading H files directly. The HBase daemons, all the overheads involved with managing data internally to HBase and the particulars of its API are bypassed, which is good and a bad thing. It's good in the sense that if you have a performance-dominated use case, you can get maybe 5% higher throughput, 5 times higher throughput. You're essentially streaming H-file data directly to your client out of HDFS without HBase in the middle. But it's not recommended from a security perspective because all of that bypass, of course, bypasses all of these nifty new access control features that I've been talking about. And finally, we have REST streaming scans, where before the HBase REST gateway would issue, when trying to service your request, issue scans internally to the region servers on the cluster, batch up a certain amount of data, and then send it back in one HTTP transaction. So you can imagine if you're iterating over a large result set, you might have many HTTP transactions and a significant amount of overhead. So this introduces a new scanning mode where, oh, and another thing about the way that you do scans with the REST API, it's not really RESTful. You have to create, in effect, a scanner resource and then do multiple requests to that scanner resource, and then finally delete it. So this is really a one-to-one map of the kind of actions you have to take with the HBase API, but it's absolutely not RESTful, which says that it should be stateless, right? If the REST gateway dies, you shouldn't have to start over. And so this mode allows you to do that. The client is the one that manages paging, how far along in the scan you are, how much you want returned in a particular batch, and also it is possible to stream the entire result set back now on a single HTTP connection, which can significantly reduce overheads for large scanning cases. So going forward with the 98 branch, I think that after .0 we'll add bug fixes and performance improvements, fix a bug that prevents us from compressing tags and H files to date, look at those performance improvements for encryption and the encrypted write-ahead log, especially that I was talking about before. And although we had this policy that we would accept breaking binary API changes from 96 to 98, of course, in minor releases we won't do that. So the binary API of 98 is set as soon as the RC is loaded in as .0. And that's all I have for prepared material. If there are any questions, I can answer them now. Yeah.
I was wondering, I guess I could leave it here. You don't want to answer. If you enable encryption, is it like enabling compression? It's going to encrypt over time? How do you know it's done?
I'm sorry. It's like enabling compression. How do you know when it's?
Right. So if
oh, right. Yeah. So if you have existing table data and you turn encryption on, you have to trigger a major compaction, at which time, when the major compaction has completed, all of your data will have been rewritten into encrypted form.
So it works the same way.
Yes, exactly. And that's actually how I skipped over the gory details of how you would do key rotation, because I figured that there was already too much content for the time I really have to talk about. It's something that we could talk about offline if you have questions, or consult the JIRA or the documentation or in the HBase online manual actually talks about these things. It's the same basic process. You make a change, you run a major compaction, at which time your change has fully taken effect.
But,
Yeah.
There's no multiple ways to really know when it's completely.
That's right. There's no built-in way to completely know when your major compaction has finished, except by looking over the cluster and determining that all the compaction key or all of the compaction keys are empty, right?
Or let's say like your server dies with the queue for compaction is just an error. Or just move. Like the compaction will follow.
Right. Right. Well, the way to ensure that your table data is encrypted entirely is to start fresh with a table and put the encryption specification in the definition when you're setting up the table initially.
I think it should be easy to just have like some info of the H file. There's probably that. The H file.
Well, actually, it would be pretty trivial to write a MapReduce program that iterates over all of your H files and does this check. Sure.
Or it could just be public. What percentage of the
Yeah, that's a good idea for a JIRA if you think about it later. Yeah.
Are there any concerns with encryption and going over HBase replication, like how the events are switching from one cluster to a cluster?
Yes, so HBase replication uses RPC, right? RPC is wrapped in SASL. You can specify auth-conf SASL level, right? So confidential communications at the SASL layer to encrypt that data in transit, with probably a 15% or 20% reduction in overall replication throughput, I would say. Yeah?
Can you use any control algorithm
yes, it's pluggable in the sense that we have a generic framework for encryption codecs in the HBase source code now. So you can code something to that interface and then select it, and it will work. But right now, the only built-in support is for AES. Mm-hmm. Okay, thank you very much.